Hey guys, I'll show you how to find the derivative of exponential functions. So I'll start with the first problem. So y is equal to e to the power x. So if I were to find the derivative for this function, y prime equals to e to the power x. The derivative of e to the power x is equal to the derivative of e to the power x. So let me do the second problem, which is 2. Then we're asked to find the derivative of y is equal to e to the power x squared. So how we're going to do that? We can use the chain rule. So how do we use the chain rule? So we let u equals to x squared. And then if we let this part to equal to u, then now we have y is equal to e to the power u. And then we have to find the derivative of u with respect to x. Du over dx is equal to 2x. We applied this, which is a power rule. Applied the power rule to get the derivative for this one. It's 2 minus 1. Then it's 2x to the power 1. Then that's 2x. Yeah, that is how we find the derivative for this part. And then we have to derive y. We have to derive y with respect to u. Then dy over du, it's equal to, we are deriving y with respect to u, it's e to the power u. Remember, I said that the derivative of e to the power x, it's equal to e to the power x. So same applies. The derivative for e to the power u is equal to e to the power u. Now that we have du over dx and dy over du, we have to find dy over dx, which is dy over dx is equal to dy over du times du over dx. It's equal to dy over du, it's e to the power u times 2x. Then we have to substitute back with this. So it's equal to e to the power x squared times 2x. So it's equal to 2x e to the power x squared. 2x e to the power x squared. So after from this step, we have to substitute back with that one. So that is what I did here. Yeah, let me do the third problem, which is y is equal to e to the power root x. And then from this problem that I was doing, we can see that the derivative of y equals to e to the power x equals to e to the power x times the derivative for the exponent. You see, this is this, and then this is the derivative for this part. So basically, if we have y is equal to e to the power u, y prime is equal to e to the power u times u prime. That means the derivative for y is equal to, so if we have y is equal to e to the power u, the derivative for this function is equal to this function times the derivative for the exponent. Let's apply that. We have y is equal to e to the power root x. So what is the derivative for this part? So y prime is equal to e to the power root x times the derivative for that part. What is the derivative for that part? It's firstly you have to convert it into the simplest form, which is that part. For those who are not aware of how that is done, it's done like this. That is how that is done. And then let's do that. So we have x to the power half. So that means we'll just say times x, then minus 1 there, minus 1, it's equal to negative half. So basically I've just said I had this, and then a minus 1 to the exponent, and then I times it to half. So now I have to convert this part into a positive exponent. So y prime is equal to e to the power root x times, then it's converted like this, x to the power half. Then I have to convert it again into this form, So y prime is equal to e to the power root x times, then it's root x. So now I have e to the power root x times 1 over 2 root x. I have that. So this is the derivative for this. You can simplify it further by saying e to the power root x divided by 2 root x. Guys, okay. Let me do another one. We have y is equal to e to the power sine squared x. So how are we going to find the y prime? I'll just say, let's just use the chain rule. Let u equals to sine squared x, and then y, if u equals to sine squared x, then y is equal to e to the power u. Then you have to find u over dx, which is equal to, so I have to convert this part into the simplest form, which is sine squared x is equal to sine x equal to that thing. So now I have to find the derivative for that. It's 2 then the derivative for this inner part, now we have to sine x times the derivative for sine x. It's equal to it's cos x. So it's 2 times the inner function minus 1 to the exponents. Alright, let me just show the step of how did I do that. I have u equals to sine x to the power 2. Now I want to find du over dx, so I'll just say 2 sine x, then 2 minus 1. I'm using general power rule times the derivative for the inner part, which is cos x. So my answer will be 2 sine x times cos x. Then I have to find dy over du, which is equal to derivative for e to the power u, it's e to the power u. And then I have to find dy over dx, which is equal to dy over du times du over dx. Then dy over du equals to e to the power u times du over dx, which is 2 sine x times cos x. And then is equal to e to the power. Then I substitute back with u. Then u equals to sine squared x times 2 sine x cos x. Yeah, that is it. And then let's go to logarithms. Logarithms, we have 1 y equals to ln u, then 2 y is equal to ln x squared, then 3 y is equal to ln root x. So y prime, I'm doing number 1, y prime is equal to 1 over u. The derivative for ln u is equal to 1 over u. Then let's do the second part. Y is equal to ln x squared. Then let's let this part equals to u. Let u equals to x squared. And then y equals to ln u. And then we have to find the derivative of u with respect to x. It's du over dx is equal to 2x. And then I have to find the derivative of y with respect to u. Dy over du is equal to 1 over u. Remember, the derivative for ln u is equal to 1 over u. So the derivative for ln u is equal to 1 over u. And then dy over dx is equal to dy over du times du over dx, then is equal to dy over dx equals to 1 over u times du over dx is equal to 2x, then is equal to, then substitute back the value of u, which is 1 over u equals to x squared times 2x, then is equal to 2x over x squared, then that equals to 2 over x. So that is the derivative of ln x squared. Now let's do the third one, which is ln root x. Y equals to ln root x. So first of all, we have to convert this into, let's just, another thing, you can always do a shortcut, but I don't prefer a shortcut. I always prefer to use chain rule to show the steps of how did I find the problem. So, but if you're a lazy person, you can just do this. Y prime, let's say I have y is equal to ln u, then y prime equals to 1 over u times u prime. That is how you can do it if you're a lazy person, but I prefer to show the steps. That is chain rule. Excuse me. Then but I don't prefer this method. I prefer the chain rule to show all the steps. So let me just do it. First step is to let this part equals to u equals to root x, and then if root x equals to u, then y equals to ln u. Then I have to find the derivative for this part with respect to x, so I have to convert this into the simplest form, which is x to 1 over 2. Then I'll just say du over dx is equal to, then I'll just minus 1, then I'll be left with, I'm left with negative e exponent, which is negative half, then is equal to, then I have to convert that negative exponent into a positive exponent, so it's is equal to, then times 1 over root x, so du over dx is equal to 1 over 2 root x. Then I have to find a derivative for y with respect to u, so dy over du is equal to 1 over u. As I've said earlier on, the derivative for ln u is equal to 1 over u. So now dy over dx equals to dy over du times du over dx. So this part equals to this part equals to that. Let's substitute. It's 1 over u times 1 over 2 root x is equal to 1 over this part equals to this part, root x times 1 over 2 root x. x. You can simplify further using algebra and stuff, but then this will do it. Thank you guys. Let me just do another one, the last one. Y is equal to ln cos squared x. Ln cos squared x, alright, plus e to the power ln x squared. Let's see. So we'll use the sum rule, the basic power rule. I'll use those two. So how can I find the derivative for y? I'll just say y prime is equal to d over dx, which is ln cos x plus d over dx e to the power ln x squared. So I'll find the derivative for this part and then add it to the derivative for this part. So let's first find the d. Sorry, it's not clear now. D over dx ln cos x is equal to. So we let's just let u equals to cos x squared. Then we have to find the derivative of u with respect to x. It's du over dx is equal to, so derivative for that, it's 2 cos x, then minus 1, we're left with 1 times the derivative for this part, which is negative sine x. Then the answer is equal to negative 2 cos x sine x to negative 2 cos x sine x. So then if we let this part equals to u, then y equals to, remember, y is equal to ln cos x squared. So if we let this part equals to u, then y equals to ln u. Then dy over du is equal to 1 over u. Then we have this part, which is dy over dx is equal to 1 over u times, should have indicated somewhere, that dy over dx equals to dy over du times du over dx over dx over dx. So it's dy, no, it's not gonna fit. It's dy over dx is equal to dy over du times du over dx. Yeah, I just wanted to indicate that. That is why I was just messing up my work. So dy over dx is equal to, you have to substitute this part. So dy over du is equal to 1 over u. So it's 1 over u times this part, which equals to this part, which is du over dx. It's negative 2 cos x sine x. And then is equal to, substitute back with this value, which is equal to that part. So it's 1 over cos x times negative 2 cos x sine x. Then this value is equal to negative 2 cos x sine x divided by cos x times cos x. So this goes with one of these, so the answer is equal to negative 2 sine x over cos x. So that equals to negative 2 tan x. Yeah, so this part equals to d. So this part equals to, and this part equals to this part, or this part, negative 2 tan x equals to negative 2 tan x. You see, now we have this part. We still need to find this part. We still need to find this part. So let's find now this part. So let's just say y equals to e to the power ln x squared, e to the power ln x squared, and then dy over dx is equal to dy over du times du over dx. That is chain rule. Let's let u equals to x squared, and then find the derivative for u with respect to x. It's du over dx is equal to 2x, and then y is equal to e to the power u. Since we let x squared, sorry for that, sorry, this equals to ln x squared. that equals to ln x squared not x. So this equals to, let me just start over, u is equal to ln x squared. So derivative for that is du over dx is equal to 1 over x squared times 2x is equal to 2 over x. Then we have to find du or dy over du is equal to e to the power u. Derivative of e to the power u is equal to e to the power u. Then dy over dx is equal to dy over du times du over dx. So dy over du is equal to e to the power u times 2 over x, 2 divided by x. So du over dx is equal to this value, du over dx equals to that value, then dy over du equals to that value. Then this is equal to e to the power u equals to ln x squared, then times 2 over x. So we can just say 2 divided by x e to the power ln x squared. So that is my answer. So this answer is for this part. So now let's substitute back. It's negative. So let's substitute back. The du over dx ln cos that equals to negative 2 tan x. So it's negative 2 tan x plus this, which is the derivative for that, so which is 2 then e to the power ln x squared divided by x. So this is the derivative for that. This is the derivative for that. And then yeah, we're good. Thank you guys. This was it.